Panama. A skeleton, 1,000 years old. At first, nothing unusual. Worn bones, a forgotten life. But inside, a secret that should not exist. DNA that doesn't belong here. Not American, not local. Markers from people thousands of miles away, across the Pacific. How did it arrive? And why does this single skeleton threaten to rewrite the story of the first Americans? Most of us carry ghosts in our blood. 2% Neanderthal, a trace of Denisovan. But fossil PV-173 from Panama was different. Not a trace. Almost entirely Denisovan. Nearly 80%. A level once thought to survive only in far-off Pacific islands. Papua New Guinea and Australia. So how did it end up here, in Central America? It doesn't bend the rules of migration. It breaks them. If this is true, then history itself has been told wrong. If this DNA had come by land, from Siberia into Alaska, we'd see the signal in the north. But the northern trail is silent. No Denisovan spike. No Australasian ancestry. So how did a Pacific signature appear in Panama? One theory, by sea. Picture rafts pushing into endless horizons. Families carrying fire, tools, memory, and genes. PV-173 isn't alone. Other fossils whisper the same anomaly, scattered across the Americas. Different times, different landscapes. Each test deepens the mystery. If the pattern is real, it doesn't just add to history, it rewrites it. Could ancient voyagers really have crossed the Pacific this early? Tell me what you think in the comments. But perhaps the answer isn't in maps. Perhaps it's written on faces. DNA doesn't just trace migrations, it sculpts us. A Denisovan sequence thickens the upper lip. A Neanderthal variant widens nasal cavities. Extinct cousins, still etched into our living features. Step back 40,000 years. In China, the Qianyuan man carried both Denisovan and Neanderthal DNA. His genome connects Native Americans, Papuans, Aboriginal Australians, even the Andaman Islanders, a ghost ancestor bridging worlds. In Mongolia, the Selkit woman echoed the same traits. Altitude, survival, repeating signatures across time. Together, they left breadcrumbs. From Asia, across Siberia, into the Americas. But then the trail vanishes, only to reappear here, in Panama. Why Panama? Why here? And if mysteries like this fascinate you, hit subscribe, because the next discovery is even stranger. We're at the Isthmus of Panama, only 100 kilometers wide, yet one of the harshest corridors on Earth. Swamps alive with insects, rainforests heavy with heat, jaguars stalking the undergrowth. Imagine stepping into it 13,000 years ago. Every breath, a struggle. Every night, alive with predators. Most groups failed, but a few endured. And their DNA proves it. South American genomes show a genetic crash, a bottleneck. Picture a family tree, 95% of branches cut away. Only a handful remained. Every indigenous South American descends from those survivors. Panama wasn't just a crossing, it was a filter, a crucible of survival. Would you have survived the crossing? Drop a yes or no below. But nature wasn't finished testing them. The real trial was still ahead. Around 12,900 years ago, the world plunged into chaos. The Younger Dryas. A sudden cold snap. Mammoths vanished, mastodons collapsed, giant sloths disappeared, and the next species on nature's list might have been us. For humans, food chains broke, starvation spread. The only hope, move south, fast. DNA aligns with the climate record. Migration surged as ecosystems failed. Panama became the funnel once again, a crucible where climate, geography, and survival collided. What emerged wasn't just endurance, it was transformation, a reshaping of humanity itself. That bottleneck still shapes South America today. Modern genomes carry fewer variants than the North, but what remains is extraordinary. Genes for high-altitude survival in the Andes, for heat tolerance in the Amazon, for cold adaptation in Patagonia. Not just survival, adaptation to extremes. The same DNA reshaping itself for opposite worlds. Even pathogens left their marks. Immune systems in the south diverged sharply. From fewer than 1,000 survivors rose civilizations. Tiwanaku, the Inca, the Mapuche, all bearing the genetic mark of Panama's crucible. Survival had not ended the story. It had transformed it. But transformation was not the final word. Why do some South American genomes carry more Denisovan DNA than their Asian ancestors? How did Australasian ancestry leap the Pacific without leaving a northern trail? Were there forgotten voyages across island chains? Or migrations erased by time? Each discovery brings us closer, but each answer sharpens the unknown. Because sometimes DNA reveals more than history is ready to accept. This is the power of ancient DNA. It doesn't embellish, it doesn't forget. It records everything. PV173 from Panama tells an impossible story. Denisovan signatures, Australasian markers, Neanderthal traces, all funneled through one narrow corridor. When scientists decode ancient bones, they aren't just analyzing fragments, they're reading the legacy of survival itself. So what's your theory? How did Australasian DNA reach the Americas? Let me know in the comments. And if you want more ancient mysteries rewritten by science, make sure you subscribe, because this is only the beginning.